Okay, actually coding them is so complex they hit the button. So I'll show you how you can find the button for coding smart parts or changing the code of smart parts. You have to go here in view. Just a second, let me see how they are in English. In extra 00 Romania. In tools, customize. And here you'll have to say more tools with icons. And you will find it's called the edit smart part by script. Here is the button, modify smart part using script, and you can drag the button somewhere, here for instance. And then we go here, modify smart part using script, and click on a smart part. Okay, make sure we selected the smart part and not a rebar. Okay, so I've sent you also a tutorial on smart parts, but I don't think it's that relevant. It teaches you how to make a parametric table, but I don't think you need a table with chairs and everything. So how this works, you have to define parameters, which can be anything you like to change. So any parameter, both dependent or independent. So you can also get parameters that are dependent on other values, not necessarily the parameters that will be inputted by the user. So from scripting smart parts point of view, you have to be a developer. You're building a smart part that other engineers will use. So these are just some codes, some names for the parameters. Then on the right side, there's a dimension. Then there's the type of the variable. It can be integer, color, boolean. It has some possibilities of types of parameters. Then there's a description, so someone else knows what this is about, this parameter is about. Then there are values. They start all with a standard value. There are some attributes here, and I don't know what are these as. Okay, these are possibility of exporting or not some parameters. Then there's a master script, which is a script that runs before other scripts. For instance, we have here steer x, which means how do we calculate the steering, the variable reference x. So in order to draw a stirrup using the code, we have to start with analytical geometry. We start from a coordinate system and we offset it with we see here from a point we start drawing that box. We have to reference with the stirrup diameter minus 2 concrete cover on x and on y. Then the stirrup length or placement length is determined by the maximum z of the column minus 2 concrete covers. And if they are all less than 1 millimeters, do you think they do some sort of rounding? Then there are parameters for some scripts for parameters. Reference XYZ is the start point of the drawing with this code. And there's a range, so there's somehow a limitation for the minimum drawing. Then there are values that come in a certain range and with a certain steps. So we don't draw millimetrically everything. So we draw something at multiplication of 5 centimeters. And for each type of parameter, you get these values. You impose some values that the user can choose. So not to choose rebar diameters that are not available on the market. And also there's here some restrictions. If something is clicked, then maybe some options are not available. There's also something regarding the code. So once you change the code to get certain reinforcement from that code. So these are all codes that create relationships between the parameters. So this is why they're called parameter script. And also here, things get more complicated. First program 0 and you get some arguments, and they say here this is how you control bar diameter, concrete cover, uh, reinforcement ratio, and other options. Then there's this dialog script. You can script the dialog with the user. So where I typed the diameter and other values like the column dimensions, you have to code this as well, or you can change something that is already coded. So you have to design also the interface with the user and decide which parameters can be inputted by user and which parameters are dependent of what the user inputted. So mainly, of course, this has a help in Allplan. Anytime you don't understand something you are working with, if you click F1, you'll get an online updated help specifically on that problem. For instance, now I'm in the smart parts and I can see more about commands, how they work, what these parameters do, and then get even in more details, syntaxes and whatever. So this is also something to remember. Anytime you don't understand the function, how it works, you just click F1 and you get explanation for that particular. So this is also explained here. For each command you see here parameters, so syntax and the short description. Then there's the 2D script and the 3D script. 2D is for smart parts which are designed in 2D, and 3D is for 3D geometry. These are placing of the handles, because we also have those handles I just pulled to lengthen the columns. There's a layer, so everything we draw is placed on layers, and there's initiation of the reinforcement. So actually they will first draw somehow a box, and then there are some references which describe what all these commands do, but it's not really easy. And also here there's a reference. If you are friendly with this code, maybe there is a chance for you to understand. I can also show some smart parts developed by me which have 10 lines of code, not 100 or hundreds of lines like this. They are easier to explain, but I gave up of developing smart parts as I don't feel it's a market for them. I mean, it's a really big work to do, and the results cannot cover everything you do. So even if you code, you cannot, if you have a hole in the column because, I don't know, you need a pipe there, you cannot do it with scripts for any situation. So this is why I don't really recommend. I'll also show what I developed, because I can easily show you exactly how these functions work, or what would be the thinking difficulty of a code, because this is one aspect. Also, you have to think the code parametric. Even if you hire a coder, the coder will know nothing about engineering or how to reinforce, or what is reinforcement, what is a column. You need somehow on a paper to draw the entire workflow process and think about all the dependencies needed. So the mathematical thinking needs to be done by an engineer, and only the coding should be done by a coder. So it's quite a big work, and I don't see a big price. So you can buy smart parts already developed on Allplan Connect. They are quite cheap. So this is another aspect that didn't encourage me to study that, because if there were no big earnings from such a complex job, I somehow gave up. I'll show you some smart parts designed by me. So for instance, this is something really simple, but I found it useful. I actually need it for school and for some real projects. It's a rafter with piles. So what does this do? The smart part. I'll show you exactly how it was created. So I have some simple parameters. Well, unfortunately, the description is in Romanian. This is an interface. So basically how it works. You just double click it, and you have some parameters: the length, the width, the height of the pile, the number of rows, the radius, and the number of piles on the other. These are the rafter or the slab parameters. So for instance, we can say 15 meters and they change. So the width 15 meters as well, and they also change. And this is the thickness. I can say 1 meter. This was actually done really easy. I'll show you how. And these are the piles. So I can change the piles to be 8 deep or 12 meters deep. Then there's the radius of the piles, can be 60, 1 meter piles, and then I can control the distance. I can get 3 piles. I can change the spacing from, let's say, overlapping, how much this pile penetrates. So I can have 0 penetration. Okay, actually it's like this. Here it's what I'm doing, we can see here. So no, let's say no stiff connection or a stiff connection between the piles and the rafter. And these are some dimensions for the distances I impose. I can say 1 meter, half a meter, from the distance from the edge of the first pile. The way I done it was with let's say regulated spacing. So I impose a regulated spacing and it automatically calculates. I only input the number of rows per X and Y direction and it automatically updates. So this is my first smart part I created and I'll show you how this actually works. So if I go here, I'll show you the code. So these are the parameters. You've seen the dialog interface. It was quite simple, only 3 tabs, and these are some parameters. And I'll jump to the code. I told you it's 20 lines. So at first I define a box, which is the rafter. The box has ABC parameters, which stand for length, width, and height. So I create a box in the geometric center. Then I have to create the first pile and I calculate my distance X, by having the length of the rafter minus 2 concrete covers, and I divide by n minus 1, n being the number of piles per one direction. Then I go for distance Y, where I take B, the width, and remove the concrete cover, and actually this is another concrete cover, but rather the diameter or the distance from the margin of the rafter, and I divide it by another number. And then I have to translate it. So once I created the box, I have to move the local coordinate system to be able to place the first pile. And this is a translation of the coordinate system on XYZ. And because I wanted to place more than one pile, I had to use this for cycle. So I created a G from 1 to the number of rows, and then created a cylinder with the function cylinder. You get access to all the syntax and all the functions. So the pile is nothing but a 3D cylinder with 2 parameters, length and radius, and then I get another circle of placing them on the line. So I have 2 for cycles because I have lines and rows. So this is how I achieve this. It was a lot of thinking, although there are 24 lines of code. It was a lot of thinking of how to do everything. So it took a lot of time to do it, actually. So it may be nice, it looks like a toy, but I cannot use it for a bridge, for instance, because for a bridge you cannot always have rectangle shape. So it's somehow limited, and also I didn't place handles. I have another more complex smart part I'm going to show you, where I also place some handles. So this mine doesn't have handles. I can only input from here the dimensions. Another element I designed was a reinforced pile. So this one, I'll do a copy of it. So if I double click here, these are parameters. This is also with reinforcement, this one. So this is a reinforced pile I can actually place it in another drawing so we can see it better. Okay. Oh, I won't place it now. So this is just a pile. Maybe I just move it from that rafter so we get a good view of it without getting obstructions. So it is parametric, this one, also with handles. So I can do tricks like this on it, and it will. At that time they didn't develop the spiral reinforcement, but now also the spiral reinforcement is available in this coding. So this is a short graphical guide on what parameters, the concrete weight, the angles, radius, placements, whatever. Then there we have the geometry, which can be 8 meter, 10 meter, the geometry of the pile. Then there's the radius of the pile, so I can control here the radius, or I can control the radius even here, so it will automatically update this reinforcement gauge. I have two parameters, one is the length of the pile and the other is the radius, and everything will adapt accordingly. Then there's the reinforcement. I can input the number of rebars. There can be 3 rebars, 6 rebars, whatever. I can choose the parameter, and it's quite fast. The diameter of the rebar can be chosen here. And other like distances between rows. So this is only for distance. I don't know what this controls. This is how much I get outside, so I need to somehow anchor this pile inside the rafter, so I can control this extra length, 1.5 or 0.5. So this is only an anchorage that exceeds the pile geometry. This is the concrete cover I can use, so it offsets the reinforcement from the concrete. And this is at the base, some concrete cover, and this is the steel quality I use. And there's the anchorage. I can change the hooks, I can change the angle of the hooks, so everything is parametric. Okay, 60. And also the length of it for the beginning or for the end. And these are parameters for the stirrup, where I can also change diameter, overlapping distances. So for instance, this overlapping is too small. I can change it to 0.1, 0.2. We'll get a bigger overlap. I think it updates in real time. This is only the length of it, 0.2, 0.2, and the angle of it. So if I hit escape, I can update all the other smart parts or not. And somehow it is somehow faster than manually doing all the reinforcement of 3D, but it's a lot of work to do. From my point of view, it's a lot of work that it's not valued if only used by an engineer. So if you only want to develop for yourself, I don't think it's really worth it. If you think of developing reinforced smart parts and sell them to more rich markets like the German market or English market, so markets that are willing to pay this type of work, it can be done. Otherwise, I think traditional is faster if you're only focused on design. I'll show you in the ending how this was created. We have here the parameters. Of course, we have more parameters than before with the rafter. We have a lot of parameters because most of them control the rebar, the hooks, the overlapping, the spacing, whatever. Here we have some scripting for the parameters of the reinforcement, so of the parameters. So I just limit the diameter range. Then there are some qualities for the steel, again some diameter. Then there are some parameters for the scripting, so I impose some ranges for maximum and minimum. And then I define a radius because the radius was missing. I only had diameter, so I created the object radius minus the concrete cover divided by 2, and then I establish what the spacing should be, because the spacing is a polar spacing, so I needed somehow to convert as a 360 degree, or the angle imposed divided by the number. This is for the interface I've just shown you, and here is the script. The first part only controls the cylinder, so there are some handles placed that control the height and the radius. Then there's the cylinder, which creates the concrete part and has some particular values. There's a translation of the system of coordinate, because I need to translate it in order to place the bars. And then we define the reinforcement longitudinal bar, and here are a lot of parameters that you get in the description, what this in the help, what each parameter does. One is for concrete cover, quality, and hook properties, and then there you have a function to place the reinforcement. So once you create the rebar, it's actually like the reinforcing, only that you do everything by code. So you first define the shape of the bar, and then you place the bar. And then, of course, I have to define also for stirrups, and you also move. So you have to move analytically through where you're creating objects. So this is how I coded this. It doesn't look like much, but it's a lot of work and a lot of thinking and a lot of testing to achieve something like this. And personally, I decided to abort developing smart parts. You also have the benefit of translating. I didn't translate it, but you can translate it. It has this option of identifying all text developed. You can develop it in your language or English, and then use some partner to translate it in German or French or whatever. They translate all attributes, and then it can be available worldwide. And also you can password protect your work. You can add the password, and you protect your work from other people snooping around your code. But mainly this is what I can show you regarding smart parts. There are many smart parts available on Allplan Connect. You can create a free user here. I think you know about this site. Is it true? You know about Allplan Connect?
Yeah.
Okay, because as a client you have some objects that you can download there, and most of them are free. I forgot my password, I don't use it that often. And you can drag and drop. For instance, this is an interesting smart part, and it's available for free from the software. Once you install it, you just have to look for it. It allows you to do some, let's say, organic modeling, so you can choose the triangulation and obtain some complex shapes. So, but anyways, I don't think that is your interest right now, to do organic shapes. This is architect's job, but there is these options if you really like parametric options. And here we can also see what is behind this shape. If you understand this code, you can get inside and change it, but it's no easy thing, I tell you. Okay. Yeah. Okay, so that's my
So
presentation
what?
for
So today we are closing.
what?
What what is now next? You are going to do
Yes.
some